All right, what's up, everybody? Welcome to Geology. Let's look at this earthquake in San Francisco that took place during the World Series in 1989 and was broadcast live on TV. It was just before the game started. People were mostly in the stadiums. Um, and in fact, they attribute that to what might have been a worse disaster because it was in an unusual thing. It was San Francisco playing Oakland, two towns right across a bridge from each other. So a lot of people were either at the game or ready to watch the game, and that may have decreased volume on some of the highways and out there. That may have saved some lives. Either way, we're not going to get into necessarily the numbers here. What we're going to do is figure out how to locate where an earthquake took place. Where is the epicenter? Right. So there's like what's the most amount of stations you can have out there in a practical sense? Like what density can you have? They're not going to be everywhere. So where are they? And then how do they tell how far away it is? And the trick is, it's a trick that you may have done. If you've ever done this thing where you see the lightning happen and then you wait and you count and you hear when the thunder happens and you use that to kind of figure out about how far away the storm is, it's the same exact idea. So in that case, let's say lightning, and then you go 1 Mississippi, 2 Mississippi, and then you hear boom. You say maybe that's about 2 miles away. Think about that in terms of this graph. You've got something that goes faster, that's the green line here. You got something that goes slower, that's the purple line here. Just like light and sound. And you use that increasing gap to figure out a distance. We're going to do that, but a little bit more precise than just counting. If we take this and figure out how far apart those are, then we can go down to that chart and do it. That's the goal here. So I haven't had you do this yet. I really think this is going to be easiest if you can find somewhere to print at least these 2 pages, the first 2 pages of it. If you can do that, I think it's going to be way easier. It's not impossible to do on the computer. And I think this drawing thing I'll just skip because then you'd have to draw it on paper and then figure out how to scan it. So let's skip that for sake of the online class. But I really do think your life's going to be easier if you print these, because then what you can do is this scale right here. It's marked on the bottom one, but not on the others. You could like copy that onto a little piece of scrap paper, and you could see exactly how far apart these are. Right. So you got. Yeah, so just break it down by minutes, see how far apart it is, and you'll be in good shape. Okay? So how much time passed between the arrival of the P and the S, just like lightning thunder. And you can see here it's the shortest, here it's in the middle, and here is the longest. So right away, maybe we should figure out which station is closest. Hint, hint, it's that one. And which station is furthest. Hint, hint, it's that one. And really what this graph is then is just, well, where is it exactly that far? So how to do that is take however much time passed in between the two, and again, use a little scrap piece of paper and measure that out. So the one they gave you here is, what if it were 1.5 minutes? So you take your piece of scrap paper, you lay it right on here, and you put dots on it for 1.5 minutes. And then what you're going to do is slide it, slide it, slide it, slide it, slide it until you find the spot where these two are exactly 1.5 minutes away from each other. And when you do that, your answer is sitting right there. That would be how far away the earthquake is if 1.5 minutes passes between. So the whole thing, like this gap is the question. This is the lab right here. How much time passes between P and S? So how much time passes between P and S? Where is it exactly that far apart on this graph? Just come on down and tell me that distance. Shoot me an email if you get frustrated with it. I can help out. I've got some other ones that I've used for high school kids in the past. I can shoot those out too. Let me know. All right. So again, I really do think that's going to be easy to print it. Then what we'll do, I'm going to have you just skip the circle drawing thing just for sake of the online stuff, and that you got that test that's due this week too. So you'll get the difference in time. Those will be times according to the scale. You'll use this, and then you'll get distances. Now, if we were really in class, then we would take those distances and we would draw circles. And the idea is that wherever 3 circles intersect, that's the spot. Now, let's say Reno was one of the stations. If we say, oh, it's, let's pretend it's this. And again, I'm just making these numbers up. It's about 575 away from Reno. So I would come down here. I'd say 575 is about that big. I'd use a compass, right? And I would say, really, the earthquake could be anywhere on a circle that's radius 575 around Reno. Look at that. That's a beautiful circle right there. Close enough. Um, so it could be anywhere on that line, which isn't much help. But so if you do it with a second one, then they're going to intersect at two spots. And let's get rid of one misconception. Let's say we did it around LA and we said it's a perfect circle right around those. What people will say is, oh, well, the earthquake must be here in between those two. And that's wrong. Where the earthquake would have to be is either there or there. Those are the only two spots that obey both situations, that are both that far from Reno and that far from LA. So you do a third, and then you would get the exact location. Now, I'm not going to have you do it, but that's the idea behind it. All right. Now, the amplitude thing's kind of neat. I suppose printing this page out would be necessary too. So ignore my print all the way to page 4. How tall does the tallest wave get? And then how far away is it? And then it's really just, it's quite easy. You'll just plot, and throw a straight line. Read these directions for more specifics. Give it a try. This is kind of like, there's no earth science lab geology lab that doesn't get through this. So we got to do it. And I know the printing thing's a pain. I'm a little less concerned about this one, but let's see how it works. Yeah, it tells you what to do there. Put one on the right, one on the left, draw a line, and wherever it meets will be the magnitude. All right, I'm going to skip the Sumatra part because we didn't really draw these lines much. I think that might be a little bit tricky. And then the last part, I think it's fairly easy, which I guess might be mean to say if you struggle with it, right? Check it out. And again, if you run into trouble, let me know. But it's all playing with this website just to check out like current earthquakes that are going on right now. I'll look through, and if there's any like ones that people are stumbling on a lot, I'll send an email to everybody. But check those out. It's just changing some settings, look at where some earthquakes take place, looking at some in New York, and shouldn't be too bad. All right. Hope that goes well for everybody. Please email if you have any questions, and we will talk to you soon.